am Rajadashini, and with me are my teammates Shanmuga Priyan and Yuvana, and we are SCSI Group 4. This is a presentation of our SC1015 mini project. This is the content of our presentation. Our dataset is on video game sales and ratings. But why video games? Video games are a form of entertainment, but also a significant cultural and economic phenomena that have evolved into virtual experiences that engage millions of people globally and influence popular culture, technology, and media consumption. Let's look at our dataset. Our raw dataset contains 7 categorical data, which are name, platform, year of release, genre, publisher, developer, and rating. It contains numeric data such as domestic and global sales measured in millions, followed by critic and user score and count. Our raw data contains 16,928 rows and 17 columns. Our motivation for this project is to predict the global sales from various game-related variables to gain insights into consumer preference and market dynamics. The model we use for prediction are linear and lasso regression and radial basis function network, which we will explore later. Now, let's look at the data cleaning process. From the basic exploration of data, we found out that our data contained many null values. Hence, we removed them. We also noticed that our numeric variable user score had an object data type. Hence, we converted it to numeric. We also found the outliers in the data using the interquartile range method and removed them. Finally, due to the large number of outliers in Japan sale and user count, we dropped the 2 columns to increase accuracy. Regression models need numeric input, but our data contain categorical inputs in object type. Hence, to convert categorical input to numeric, we use target encoding, which replaces the object input with a number that represents the mean target value, in this case, the mean global sale for each category. Target encoding was done for categorical variables, platform, genre, publisher, developer, and rating. Our clean data set has 3,186 rows and 20 columns, including the newly added target encoded column. Moving on to EDA. For univariate numeric, we did box plot and histogram. Box plot shows median, quartile, symmetry, and spread of data. Spread of data is similar for all sales. Global sale has the highest mean, followed by NA sale, EU sales, and other sales. Histogram, most importantly, shows frequency. From histograms, we can analyze that a critic score of 72 and user score of 7.8 have the highest frequency. For categorical values, we did histogram, but before that, we grouped the year of release in the following manner, as there were too many categories. Correlation matrix was used for multivariate analysis. Columns with high correlation with global sales are North America sales, other sales, Europe sales, and main developer. The final stage before machine learning is data preparation. We split the train and test data according to years, where the train data is from 1985 to 2009 and test is from 2010 to 2016.
Let us now look at linear regression. Linear regression is a statistical method used for modeling the relationship between a dependent variable and one or more independent variables. The basic premise of a linear regression is to fit a linear equation to the observed data points to best explain the relationship between the variables. Mathematically, linear regression can be modeled using the equation on the slide, where y is the dependent variable, x values are the independent variables, beta values are the coefficients of the independent variables, and e is the error term. Moving on to the code breakdown. We perform linear regression individually for each numeric and categorical columns. For that, we first did data preparation, followed by model fitting and prediction, model evaluation, result storage, visualization using regression line, and finish by creating a data frame. For the results of linear regression on numeric columns, we deduce that NA sales variable has the R-square value which is closest to 1 and also has the lowest MSE and RMSE values, suggesting that it well fitted to the data. For the results of linear regression on categorical columns, we deduce that the mean developer variable has the R-square value which is closest to 1 and also has the lowest MSE and RMSE values and is the best suited to predict global sales. Now let us discuss lasso regression. What is lasso regression? Short for least absolute shrinkage and selection operator, it is a regularization technique that applies a penalty to prevent overfitting. It enhances the accuracy of statistical linear regression models. The equation of lasso regression is where the RSS is the residual sum of squares, lambda is the regularization parameter, p is the number of features, and beta j represents the coefficients of the features. For the process, we began by building and evaluating a lasso regression model for numerical and categorical columns individually, and then proceeded to do the same for both numerical and categorical columns together. Let us now look at the code breakdown. Firstly, we did data preparation by dividing the data into train and test sets. Then we generated a lasso regression model without hypermeter tuning by first scaling the data using a scaler. After that, we used Grid Search CV to do hyperparameter tuning, and finally plotted KDE graphs to visualize the results. So let us now move on to the results. Firstly, for the numerical columns from the KDE plot, we can observe that both the y-test and ypred2 graphs follow a similar shape and spread. However, since the peak of y-test graph is considerably lower than that of ypred2, there might be notable discrepancies affecting the accuracy. Since both MAE and MSE values decrease after hyperparameter tuning, and the value of R-square increase, the best alpha value found by the Grid Search CV for the tune model is 0.01. Secondly, for the categorical columns, from the KDE plot, we can observe that the y-test and ypred2 are dissimilar in shape and spread. The peak of y-test graph is also significantly lower than that of ypred2. This suggests that there's a notable discrepancy between the actual global sales and predicted global sales. On the other hand, both MAE and MSE values decrease after hyperparameter tuning, and the value of R-square increase. The best alpha value is 0.01. Lastly, let us look at both numerical and categorical values. The KDE plot is relatively similar in shape and spread. However, since the peaks are different, there might be a slight discrepancy in the model's prediction. Both MAE and MSE values decreased after hyperparameter tuning, and the value of R-square increased. The best alpha value is 0.01. The coefficients have changed significantly, and some features now have non-zero coefficients, indicating their importance in predicting the target value. To sum up, lasso regression analysis demonstrated significant improvements in predictive performance following hyperparameter tuning, and by adjusting the regularization parameter, the tuned model exhibited lower prediction errors and better captured the underlying patterns in the data, and thus this method improves predictive modeling accuracy and decision-making processes.
In order to increase the prediction even more, we will be using a neural network called radial basis function network. RBF network features a simple three-layer structure: an input layer that feeds data into a hidden layer, an output layer where results are formed. The hidden layer uses Gaussian function as activation function, which assesses the influence of each neuron by computing the distance between the input data and neuron center. The distance is processed using function kernel, typically Gaussian, to determine the weight of each neuron's influence. For process of coding RBF, we run numeric and categorical columns individually, followed by all the columns. Now let us see how we coded. For data preparation, we have split the training and test data into two different data frames as mentioned before. The RBF and regressor class streamlines the implementation of RBF for regression tasks. It initializes model parameters, conducts training via k-means clustering, computes RBF value, and fits rich regression model. For prediction, it computes RBF values for new data points and utilizes the trained regression model. Behind the scenes, it calculates RBF value with compute RBF method and offers parameter handling for easy manipulation and integration with scikit-learn tools. Let's look at the results of prediction. The best hyperparameters found for numerical columns are alpha 0.0001, gamma 0.001, center 40, and MSE R square values as shown. For categorical columns, the best hyperparameters are similar to numerical columns with centers 30, and the MSE and R square values are as shown. For all columns, hyperparameters are same with center 60, and MSE and R square values as shown. Here is the quick analysis of models. For numerical columns, performance increases from linear to lasso significantly, but less enhancement from lasso to RBF. For categorical columns, the performance improves with lasso regression but reduces with RBF, suggests that categorical columns are poor predictors. Overall, using all the columns, both lasso and RBF model yields R-square value above 0.7, indicating effective predictors. Now let's see the outcomes and insight. Comparative analysis of R-square and MS values reveals that lasso regression outperforms linear regression, and the RBF slightly surpasses the lasso model in terms of accuracy. The NA sales, EU sales, and other sales are the best numerical columns for predictions, and developer, platform, genre are the best categorical columns for prediction. Lasso regression outperforms linear regression due to its feature selection, reduced overfitting, multicollinearity, and enhancing interpretability through L1 regularization. While both lasso and RBF effectively manages multicollinearity, the RBF yields only minor improvement over lasso due to sensitivity of RBF to hyperparameter tuning, unnecessary complexity in linear scenarios, and issue related to data size. Now let's look at how prediction related to real life. Firstly, North America sales, Europe sales, and other sales are crucial prediction for global sales and significantly impact global sales revenue as they are the biggest markets for gaming industries. Categorical variables such as games developer, platform, and genre are crucial predictors for global sales as they influence a game's appeal, compatibility, and accessibility, directly affecting its market success. That's the end of our presentation. In this project, we are able to use various ML techniques to achieve our motivation, which is to predict global sales from various game related variables to gain insights into consumer preference and market dynamics. Thank you.